Recording. Okay. So today we're talking about programming in ROS. Let me remind you that previously we faced some terminal application of ROS. I mean that we learned that if we type like ROS core, we'll launch the master process of ROS. I also want to run the X server for Windows 10. And we found out that if we run the node with ROS run, then name of package turtle sim node. The command is ROS run, ROS run, name of package, name of node. If we do that, we can launch the node. That is maybe graphical, maybe not. The point is that it blocks the terminal. Right. So we also learned that we could use commands like ROS node list to find out the amount of nodes in the system. We also can run the command rqt graph to see the graph of nodes and topics that exist at the moment right now. Please, come on, do it. Yes. Nodes and topics. We also could publish something in some topics. For example, ROS topic pub, name of topic turtle one cmdvl, this one cmdvl with some type that I found out with pressing tab, and I press tab once again to put the template of message, and in this case I can publish some message and another node would receive it and execute it. So that was the brief remembering of the topic of previous lecture. Now let's try to implement some source code that allows to implement the publisher and subscriber in the node. Let me remind you that in ROS there is the one node, the one piece of code, and it can contain several publishers and subscribers. In this case, maybe we will today implement the node that contain both publisher and subscriber. But let's start with the very beginning. Let's start with creating our own package. Let me close everything that is not necessary. So the new terminal. First of all, we have to start with creating the directory for workspace, some home directory. mkdir, I don't know, my workspace. In this workspace, we always should create the package that is called src. This is like requested. Here in this path, my workspace src, we have to implement the command that is called catkin init workspace. A lot of commands in ROS that are connected to the packages begin with the word catkin. There are several commands like catkin init workspace, catkin create package, and catkin make. They all are connected to the packages, and this weird word catkin, I don't know its nature. Why is it called like that? I don't know. Well, but still, it's like the marker that if the command begins with catkin, then it is about packages. So by catkin init workspace, I create the symlink of some symlink list. Okay, we can even watch what's happening in the symlink list, but we won't find anything interesting here. There are some variables, I'm not like the profi in CMake file, but the only thing that I can find find out from this file is that here there are several environment variables that are set up, and the point of this CMake file is when you create your own package, you have to say to ROS that there are some nodes in these new packages, and therefore here you provide several you provide here several environmental variables. That's it. That's the only purpose of this command. Okay, here in this directory in SRC, you can create your own packages with command catkin create package. Then you have to put the name of your package. Hello world, for example. After that, you have to put your dependencies for this particular package. The dependencies are other ROS packages. In the very beginning, maybe you don't know any name of dependency. Well, you have at least put you should put dependency from whether ROS Pi or ROS CPP or both. It depends on which language will you prefer. Let's program with Python and use dependency from ROS Pi. What's happening here? They created one XML file, one more CMake list. Well, first of all, there was created the directory of this name. We could create it manually, but it is created automatically for us by invoking the command of create package. There is also another SRC folder that is created, and what else? And that's it. So here, if I put ls here, I'll see the package with the folder. If I change dir here, I see another CMake list. It is not connected to this one. It's just some CMake list, some XML file, and empty folder SRC. Okay, let's see quickly what's happening in these two files. Here it is the standard CMake file for C++ development. Well, here in some middle you will be able to see add executable that is used for C++ programs, and so on and so on. So important things for us is the name of package in the very beginning and the dependencies. If you missed some dependencies in the beginning, if you didn't remember them, or if you found out that you need some new dependencies, so you can put them over here manually, and this would work. Important thing, well, it is not required right now, but I just put it here as an example. Important thing that if you change the name of the package, you have to do it over here. If you just change the name of the folder, nothing happens. So if you, for some reason, made a typo in the name of package, or for some reason decided to change the name of package, you have to do it over here and in the package XML. This is also the name of package, and also over here, some in the bottom of the file, you also see the dependencies. So if you missed some dependencies, you have to put them in CMake list and in package XML, like will depend and exec depend. Okay, this is about the generated files. How does CMake list come? Is it automatically generated by the ROS? This particular file, yes, is generated by invoking command catkin create package. You can do it manually. It is not forbidden, but this file is generated for you, and there are a lot of commands that might be useful in the future. That it is required for you just to decomment them to use. There are almost all useful packages for ROS and for C++ over here. If you program in Python, most likely you won't need this CMake file at all. It should exist for, this command for finding the catkin package and this package, this macro, should be invoked for when you compile your packages. So in this case, you cannot provide the empty CMake list. You cannot do like this and expect that something would work correctly. There should be some minimal comments, but the most important comments are already done for you. The only thing that you should how to say it, you should look precisely that all dependencies are set up correctly. Now we need only ROS PI dependency. ROS PI dependency. Control save, please. I don't know what's happening. Something. No. Okay. Stop it. Let's see again. Okay, one dependency. And also in package XML, also dependencies. Okay, let's go further. Let's create our first. Before we create our first node, let's do the. Let me show you the command for making, for compiling. In the directory of the workspace, this is important, where there is only src folder, where there is the package. You have to implement, and not implement, but invoke command catkin make. And then something is happening. The important thing that appears right now, come on, please, faster. Right now, it shows that it found one package, new package. And there are two new generated folders. If we go to build, to build, we can see that there is the folder with the name of hello world. I guess it's empty right now, not empty. Well, there are some generated files. You should never look inside them. They are useless for you. They are useful for us. Okay, so 3 commands: catkin init workspace, catkin create package, catkin make. They are used to create our own package. Okay, let's go to our package and add here the node in Python. So just touch. There is no specific ROS command for creating files for source code. So touch hello.py. Important thing that since it's the Python code, we should, how to say it? We shouldn't forget to do the change mode +X for this file. If you have already programmed something in Python, you remember that the Python is the executable file, and you have to make it green. You have to allow it to be invoked. But you will never run it like this, in this way. You will run it as the ROS node with ROS run. Okay, let's do something with this node. Hello.py. First of all, we have to add the, like in every Python file, path to the interpreter. Not being user and Python. Am I right? User bin Python. User bin Python. My version of ROS Melodic, supports both Python 2 and Python 3. As you know, Python 2 is not supported anymore. Like, by supported, I mean it is not updated anymore. But a lot of things in ROS are still written in Python 2, and your final task that you would perform, the simulator for this final task, is also written in Python 2. That's why we should still keep talking about this difference. Now I'll use, as far as I remember, my default Python is Python 3. Let me just check it. Python minus version. No, it's Python 2. Okay, let's say Python 3 here. Python 3. My default Python 3 is Python 3 3.6. Okay. As far as I remember, 3.7 is already existed, but it doesn't really matter. Okay, so there is the simple example that is not very useful, and we will implement another code that does more important thing, that moves the total. Okay, important thing that first of all we have to import ROS.py. This is like where we always start. Import ROS.py. We also should import the type of messages that we will publish. Well, now we don't know what we want to publish. We just create the skeleton. So we skip the step for a while, and now we do the publisher step. We do the init node. This is also the command that should be done in the before all other ROS commands. If you try, for example, to create publisher before you init node, most likely your program will be crashed. So first of all, you have to do ROS.py dot init node, and here as the parameter you provide the name by default. What is this name? Let me remind you. Let me once again run ROS run total sim node, and put and type rqt graph. So here, this was the name of the package, and this was the name of the executable, total sim node. And total sim is the name of node inside the ROS namespace. So here, name by default, this is particularly this name. Our node is called hello.py, and when we want to run it, we say ROS run, then our name of package that is called hello world, and then there would be the name of node, hello.py. This name by default would appear in rqt graph and in ROS node list. So here we can change it if you want. Okay, then since we launched the total sim, let's create a node that would provide some behavior for the total. Let's, for example, make it move in the circle. So basically, we would need the message that receives this particular node. How can we find out the type of messages that receives this node? Well, I can stop the rqt graph. I don't like this segmentation fault. That means that something is wrong in system. Okay, we'll find out. I can say ROS node info total sim node. Total sim. So it says that it subscribes to the topic total 1 cmd. Okay, ROS topic info total 1 cmd, and it says that the type is geometry MSG twist. Since we found out the type, we can say okay, from geometry MSGs underline MSGs dot MSG. This is important. MSG, this one. So here you just put the name of package. Well, here I forgot to say that all the messages in ROS are also stored in the packages as well as nodes. So this phrase means that this is the name of the package where you can find the message of type twist. So this is the package. This means that we use this package as MSG folder, because in this package there also could be the nodes. There is no restriction for this. So we say that in this package .msg we want type that is called twist. All right. Then we have to create the publisher. As I showed in the beginning, in one node we create the publisher. Okay, we say ROS.py dot publisher. We also should create the object publisher of the following parameters. First of all, there would be the topic where this publisher should publish, the type, and the queue size. So the topic is called total 1/cmd_vel, common velocity. The second argument is exactly this twist. And the third argument is the Q size. Q, it is named parameter Q size. That is equal to something. Important thing that this Q size is not exactly that Q that you expect here. You might think that this Q works like this, that we can publish several messages, like 10 of them, and if nobody reads them, they are stored in this topic and are waiting for the subscriber. And when there are 10 of them, then the new messages will, how to say it, will be put instead of the previous one. No, it doesn't work this way. This Q size means the following. Publisher is, well, generally ROS, is the parallel system. A lot of things are happening in several threads, and publishing also happening in the separate threads. That means that when we put the publish command, this in the future, this publishing takes a little, but still there is some time for publishing. That's why if for some reason we put 100 commands simultaneously to publish, there is no way for us to launch 100 threads at one moment. And for this purpose, we specify the queue size for these particular threads. What does it mean in the for the practice? That for the super busy system, for some reason, there we specify special queue. For the system that works in the normal way, when we publish the message, for example, once per second, this queue size is not important for us at all. We can put here even one that would work correctly still, even if nobody reads the message. Let me remind you that since we are the publisher, we never mind who reads our messages. Even if nobody reads them, we still publish them, ROS still captures them, and we don't even think about the receiving. At the same time, subscriber doesn't know anything about the publisher, and if subscriber missed some messages, then it won't get it ever. Okay, then back to code. We created the publisher, so in the future we would say pub.publish. Publish. Okay, what we want to publish? Well, some message. Let's say the message. Message is type of twist. It is the object of type twist. Then twist. Twist. Okay. We don't know what is inside this twist. And to find out, we can use the command ROS msg show and this geometry msg. Hi, geometry msg. Control copy, control copy. Come on. I said control copy, control copy. No, come on. Why? Okay. ROS msg show geometry msg twist. It says that inside twist there is the field name linear that is type geometry msg vector 3 that contains x, y, and z and also angular. Okay, let's say then msg dot linear, this name linear dot x is equal to 1. It is float, so 1.0. And msg dot angular. I don't remember if we found out in the previous lecture, but the only thing that is required for total sim is linear x and angular z. It doesn't read any other numbers, despite they exist here. It just ignores them. So I want to move it forward and rotate simultaneously to make it move in a circle. So angular dot z is also equal to 1.0. Well, and after that we can publish, pub.publish. But I want to do it in the infinite loop. I want to say while not. I can do while true, but while true in ROS isn't stopped with Control C. So I have to put ROS pi dot shutdown, as far as I remember, is not just ROS pi dot shutdown. Is shutdown. We'll find out right now. Is shut down. While not ROS pi dot shutdown, do publish, and then we can say import time, import or sleep. I don't remember. Does sleep in Python work without any import? Sleep 1.0. Okay, we'll find out right now if this works. If it doesn't, well, I'll import time. Okay, now I have some source code. Yes, that every 1 second publishes the message of this type. Let's find out if it works. I want to relaunch total sim just in case. Then I go to my workspace, and I have to do cat can make once again. For Python, it is not required to recompile everything, and it will say that nothing happens. But if I forgot in the beginning to do the cat can make when I only created the package, I have to do it right now. Right now, I invoked cat can make just in the memory of C++ because when you finish your code, in C++ you have to recompile it. Okay, now I can run my package, but since my package is like my own, I have to provide also the environmental variables. When I did it in symlink to CMake file, it's not enough. In every new terminal, I have to say, please to the ROS, please add this package to your pool of packages. You can do it with the following command: source devil setup bash. Devil is the folder inside this workspace. So this is the particular file that is also generated when you did cat can make. So if you are not inside this folder, you have to specify the full path to this file, to the file setup.bash. And after that, I can do ROS run, name of my package. How was it called? Hello world? Hello world, yes. And by tab, it would put my node. And right now I press enter, and something wrong happened. What is wrong? ROS package. What is ROS package? Okay, maybe something was wrong with Python 3. Let's say just Python. Yeah, unfortunately, okay, we just found out that by default, yeah, I forgot it. By default, ROS doesn't work with Python 3. I had to do some commands in terminal to apply ROS 3, not ROS 3, Python 3. You can Google it, it's pretty straightforward to add the support of Python 3. Okay, now the code is not, in this particular code is not important which version of Python we used. So let's think that we program in Python 2. Okay, shutdown, I guess it's written in this way, shutdown. Yeah, and sleep is not defined, that's why we use import time and time dot sleep. And now it works. You see that as far as you remember, the turtle needs 1 second to invoke the command, and we put the commands every 1 second. So if I just stop it and put here more delay, for example, 2 seconds, I can run it once again, and we will see that it performs for 1 second, stops for 1 second, and so on. We will have to reconnect in 10 minutes. Well, bingo, we did something that works. Awesome. Let's just think What we could do better using ROS? First of all, I'm talking about this sleep. Let's do it in this way. In ROS, there is one special thing about sleep. This is the variable. This is called, as far as I remember, ROS_PY.rate. This is the this is the object with its special attribute sleep that allows you to sleep for exactly 1 second from the beginning of the loop. So if we put sleep of rate inside the loop, by this command we will say that every iteration takes exactly 1 second. It calculates how much time this command required and sleeps for the time, how to say it, that is enough to be once per second. This number is not amount of seconds. This number is in hertz. This is the amount of how much times per second it should be invoked. So if I say 2.0, it means that 2 times per second. And once again, this code means that the message will be published exactly 2 times per second. One iteration of loop from this point to this point takes exactly half of a second. Let's invoke it to see that I'm right. 2 times per second is not. We can see if it happens 2 times per second or 1 times per second. Let's do it 0.5, like once per 2 seconds, and see that this behavior is just the same as it was. It sends the command and waits for half of a second. The difference from the previous version is that the whole iteration of loop took exactly 0.5 seconds. All right. Then I want to show you one bug. If I just remove the cycle, if I just say do it just once, publish the message just once, let's see what would happen. Intent is redundant. The node stopped invoking, but it didn't move. I can do it again. The node finished invoking, but it didn't move. Okay, you say, let's see if the message appears in the topic at all. ROS topic, echo, turtle1, cmdvel. It is empty. We will see if now the message appears in this topic. But it doesn't. Nothing happens over here. If I put the cycle back, I press Ctrl+C to save it. Wait, closed everything. Not closed, but I want to see everything and turtle. If I put it back, everything is fine. Message appears in ROS topic echo, and the turtle invokes this message. So what's wrong? I stop it. The point is that this publisher has the constructor that is invoked in the separate thread. Unfortunately, ROS is created in this way, and in this version of code, between this publish and this constructor, there happens not enough time to complete the construction. And for some reason, ROS doesn't say anything about that. So it performs construction in a separate thread. Then it tries to create the message and so on, and it comes to the line with the publishing. But the publisher is not constructed yet, and it cannot perform publishing. But Python doesn't stop, nothing crashes, it just ignores this message. This is the weird behavior of ROS. This is unexpected behavior of ROS. But I can explain that it is logical. The common solution is to put time.sleep for even this time would be enough. In this case, if I just run it once again, no, this time wasn't enough. Okay, let's put here 1 second. Now it worked. Did you see it moved? Let me launch again and look at the total. It moved. So now it was enough. Why does it happen? This is an important thing. Topics in general are not used to send the very important information, I mean the unique information. Do you agree that this message that appears just once in this topic, this is the unique information? This information is not repeated. We do not repeat this message, how to say it, rapidly. So topics in general are not used to transfer unique pieces of messages. For these purposes, there is another mechanism in ROS. So in general, topics are used to provide, for example, coordinates 100 times per second, or to provide logs, or to provide the comments that are also sent, I don't know, 20 times per second. And if several comments in the beginning are lost, nothing bad happens in the system. So in this case, it is still maybe strange, but it is the common approach in robotics. First several messages in the broadcasting topics are not really required. If there is the message, if there are messages that are really required in the beginning, then you better should sleep to wait enough time for constructing, or you have to use another way for transferring except of topics, publishers and subscribers. All right. So, okay, it's clear for us what's happening over here. Publisher, message, rate, and maybe sleep before the cycle. And here, in this way, we publish this particular message every iteration of loop. Okay, let's reconnect right now and start implementing this subscriber. All right, this subscriber. That would be another node in the same package. Well, that is pretty obvious solution. Let's go to, well, we could implement another package for the subscriber, but why? What can stop us from doing the subscriber inside the package hello world? Cd hello world. Well, let's add another node. Touch subscriber.py, and also change mode +6 to subscribes.py. Okay, and gadget. Let me open both hello and subscriber, the publisher and subscriber, just to make some copies. Okay, we will also use Python 2. We also would use ROS.py. We would even use geometry image GIST-WIZ. I want to implement the subscriber that would receive the messages and just output them on the screen, just to check that we are able to create subscribers. Okay, also init node, and we also will need time to wait for the subscriber, or not. No, for subscriber we won't need to wait, because if the message appears before the subscriber is created, we will have nothing to do with this. Yes, for the subscriber, all messages comes in the unexpected time, timestamp. So the only thing that we can do is to wait them after we're created. We shouldn't sleep for this purpose. Okay, we have to create a subscriber. A subscriber we can do without creating the object, because we won't invoke any command for this object. It's worked in that way that we also provide the name of topic, the type of messages, and instead of queue, we provide the callback function that would be in another thread performed when the message appears in this topic. So in general, let me just wait to show you that when this is the general thread of the subscriber, and there is the general thread of publisher. At one moment, publisher decided to provide some message. It comes to the subscriber. At the moment, subscriber, not in the general thread, it spawns another thread for handling this message. If publisher comes with another message to a subscriber should do one more thread. This thread could be done for some time. We don't know the time of handling the message. The point is that a new message would be performed by handled by another thread, and so on and so on. The only thing that we should keep that the main thread of subscriber should work always to be ready to read messages. So in the main thread, we have to specify the function that would work on every thread. So in this thread, they would work this particular function. Okay, back to our code. Back to our code. Back to our code. Here we have to specify rospy dot subscriber. I hope that I didn't make it equal subscriber. To turtle1 cmd of type twist, and the function, let's not call it callback, let's call it function. So we have to specify to define this function. I like Python. It gets some message. In C++, we had to specify this type in this function, but in Python we just expect some message all along. We know that in this message there are linear x and angular z. So I'll put them on the screen. There is the special ROS function that's called loginfo that sends information from the parameters both to the screen and to the special ROS logger. So rospy.loginfo. I received %d. Okay, let's be %d. I don't remember how in Python we put the float or f. Wait, come on, this is Python, so plus msg.linear.x plus space plus msg.angular.z. Well, yeah, that's enough. And that's it. The only thing that we had to do is, as I showed previously, we have to stop the main thread from stopping. How to say it? We have to provide infinite loop in the main thread to allow it to spawn new threads for this function. Who in this fake person win? father's name. What? I didn't understand your question. Okay. Let's go further. We have to stop this. We have to handle this thread forever. So rospy.spin does exactly this thing. It allows the subscriber to work forever. It stops the main thread. So if I put here anything, it would never work. But if there appears the new how to say it, the new message, if it appears, then the main thread would spawn the thread with this function. Super parallel magic happens here. So let's check if it works. In another terminal, I do change dir to my workspace. I do source devel setup bash, don't forget it, setup.bash. Then I do ROS run hello world subscriber.py. Since there are no messages, then nothing appears here, but it blocks the terminal because I have done spin that works forever. And after that, where was my publisher? For sim. Let it be over here. So I want to look at the total. I want to see over here, and I want to do change dir to my workspace source devel setup.bash and then I have to do ROS run hello world hello.py. This is our publisher, and let's see. Yeah, shutdown request, new node registers will be the same name. This is the problem of, despite the total moved, this is the problem that over here I put the same name as this thing. So this would be our publisher by default, and subscriber by default. And once again, I run here the subscriber, and here I run the publisher. Whoa. It cannot concatenate. So you see the problem here. It cannot concatenate string and float. Oh gosh. Who remembers how to concatenate strings and numbers in Python? Like this, like str from this. Let's check it. Yay, magic. So every moment when the turtle receives the command, the message, this message is received by our topic, by our node. Okay. And also, if I do Arcuti graph, I see that there is publisher by default, subscriber by default, our nodes, total sim. They all are connected by same devel. So this is how it works. I also can. Where is my publisher? I also can both in this publisher and subscriber change the topic. For example, I call it vel11 in publisher and vel11 in subscriber. And if once again I would run the subscriber and the publisher, they would, how to say it, they would transfer the messages, but the turtle won't do anything because the turtle listens to another topic. In our Qt graph, we will see that publisher and subscriber are connected by CMDVL 111, while turtle sim is expecting from CMDVL. Okay. So this is how does it work. All right. This is your first homework. There are several steps for your homework. You have to implement the node that moves in a square. You have to do exactly the same thing as I have just done, but you have to change these parameters for moving forward or rotating. You have to do it in that way that it should move in a square. After that, you have to make it in the infinite loop. There are like steps, 5 steps of one homework. You have to do it in the infinite loop. After that, you have to, how to say it, do whether several nodes or several publishers to 2 different turtles. One should move in anti-clockwise, another should move clockwise. There is the command how to create one more turtle in the same node. I mean, if I invoke this command, ROS service call, it's another ROS command. This is special. This is exactly that way how to perform unique messages. You have to do it with services. There is a service called spawn with the coordinates. When you can in one node, so now we have only one node total sim. If I call ROS service call spawn with name Leonardo and some coordinates in the same total sim, I will see second turtle. So I have one node. Let's look at this window as on the node. I will see here 2 turtles, and they are subscribed to different topics. Once again, I will Qt graph. Turtle 1. Well, on the total sim, there would be 2 topics that they are subscribed to. One of them is subscribed to Turtle 1, another to Leonardo. And if I publish the commands to Turtle 1 CMDVL, this turtle would move. If I put the commands to Leonardo CMDVL, this turtle would move. This is the way how to publish to different topics, different commands. If it's too complicated for you, you can just run another total sim, another node, and to publish different messages to these 2 different nodes. The idea is that you have to update your code from the previous step in that way that it could move both clockwise and anti-clockwise simultaneously. The next step is very obvious, is just the same as I have just done, is to write the subscriber that outputs the position of the turtle on the screen, one of them. So the second one won't be useful for us anymore. So this step, the third step, is used only to allow you, not allow you, to show you to learn how to publish in 2 different topics. Here you have to output the position of the turtle. For these purposes, you can use the topic that is called pose, that is output topic. In this particular topic, there is the position every second. So if I right now put in the separate terminal, ask for ROS topic echo turtle 1, for example, pose, I'll see that, I don't know, 10 times per second, 20 times per second. It outputs the position. Stop it, it stares the coordinates, x, y, theta, and its current velocity. So in this topic, you can, your task here is to output exactly this thing, but not with the topic echo, but with the particular node. You have to receive this topic, the messages. This is done to make the final step. You have to write a node that gets the position of one total and makes another total to moves after it. So you will have two totals on one screen. One of them receives the commands from the terminal from total teleop key. Do you remember this node from the previous lecture? And another total moves after this one. So once again, yep, this total should receive the commands from the node from the fourth step that listens to the commands to the positions of this total. Yep, let me draw it for you. So we have in this total sim, we have Leonardo and total one. Over here, the commands would be published from teleop key, the basic node, teleop key. This topic is the input topic for another total, for that one that is hidden right now in that part of screen. But over here, there would be the node that listens to the position of total one. That would be your node. And it outputs the commands to this particular total. So you will have to convert the coordinates of total one to the, you will also need the coordinates of Leonardo to compare these poses to calculate the commands where it should move, where one total should follow another. This is your homework, your first homework for ROS. Is it clear what you have to do, or you have some questions? Okay, yes, it's clear. I have to. Okay, so once again, 5 steps. First of all, you have to find out how to manipulate with the total. Then you have to do it how to manipulate the total with the infinite loop, like when you can run your code, go to make some t, when you return, it still should move. Then you have to learn how to separate your code to 2 different totals. After that, you have to learn how to get the position of the new current total. And after that, you have to make the code that allows one total move after another. Okay, I guess that is it for today. In the next lecture, we will learn more about services. How the first service is Spawn. We will learn how do they work at all, how to call them from the console, how to write the special server or client for services. I don't think we will create our own services and perform this task, and learn how to run the nodes without infinite amount of terminals. There is a special launch files that are structured like some XML files that allow you to run several nodes simultaneously. We'll provide how to, this launch files also allows to provide some parameters. We'll learn how to read them. And that's it. Arduino is out of our topic right now. So next lecture will be final about services and ledge files. Okay. Once again, questions, screams, maybe some pain, maybe not. Is everything fine? All right, great. If everything is fine, then that's it for today. The slides are the same as the I mean that you already have the link to the slides, and I once again I will put the task to your emails, but it is just the same as it is written over here. I guess you have 3 weeks for this homework. Okay, if there are no more questions, then thank you for your attention. See you at the next week. Bye.